Hey, so I know you don't have a vector network analyzer, and also a lot of vector network analyzers. Let me actually grab one. This thing, a nano VNA. They're like $50 on eBay. A lot of vector network analyzers bottom out at about 50,000 hertz, and if you're trying to do really low frequency applications, you really can't use them to measure the properties of a coil. So I came up with another way. So I've got a function generator here. This one has a limited range, like 25 megahertz down to 1 hertz, and a pretty low voltage. I think the peak to peak is like 6.6 or something like that. I've got an oscilloscope set up here, and I've got an example of if you're trying to do tags, you could hook directly up to the LA and LB pins on a chip that's on a coil. But here's an example of what you would do for a coil that you don't have the known properties for, and you're trying to do something like figure out the resonant peak of the coil, which is basically the inductance of the coil and the capacitance of the coil, either from, like right here, I've got a capacitor, but there's also a little bit of capacitance that's inherent in between the windings of the coil. So if you're trying to figure out the resonant peak and then use that to figure out the inductance of the capacitance, and you can't use a VNA because it's low frequency or you don't have one, then you can use a trick like this. So I've got a coil, it's got a big ferrite on it, and a good amount of windings. So it should be a reasonable inductance, probably with this. I don't know. You don't have to know beforehand, but eyeball would say this is probably maybe 10 microhenries, maybe 20, something like that. And I put a, what was this, a 100 nanofarad capacitor on here. And I was hoping that between those two, the resonant frequency would go below 25 megahertz. I don't know if I succeeded in that because that's not what's showing up with my testing. And you need to make sure that you've got the coil the way it is, and then you've got a resistor, like a current limiting resistor. This one's at 10K. You could do, it doesn't really matter what the value is, just do around 10K to protect the multimeter, because there are some configurations where you can add capacitances and inductances, and it creates a virtual voltage that can damage your device. So you should definitely put some protection on there. So yeah, this is basically an inductor, a capacitor in parallel, and then that whole assembly is in series with a current limiting resistor. So when I hook this up, I would hook up the negative leg of the function generator to the ground connector on the probe for the oscilloscope. And then I would hook up the positive output of the function generator to the end of the current limiting resistor, far away from the circuit. And then I would hook up the probe tip to the other end, near to the coil, between the coil and the resistor. And that should give me an output, I'll have an output from the function generator showing up on here. And as I vary the frequency, the waveform, the amplitude of the waveform will get smaller as you get close to the resonant peak. And then once you pass the resonant peak, it'll go back up. So you'll know where the peak is because that's a voltage minimum. Unfortunately, I couldn't get this one or any of the other coils that I had working. They were too high of a frequency, or maybe I did something wrong. But I got it working on a little motor. That's a good example to try with because they have a pretty high inductance and their interwinding capacitance is pretty dramatic because of the assembly of the motor. So I'll try it on there. Okay, so I've got a coil here hooked up. Going to turn the output of the function generator on. Right now it's at 10 megahertz. I already tested beforehand, but you could go start at 0 and work your way up. But I've got, see, a waveform right here, and the peak-to-peak voltage is about 7 volts. So as I bring the frequency up, you'll see that not only does the frequency increase, but the voltage, the peak-to-peak voltage, goes down. And if I keep going, it reaches a minimum and then goes back up. See that dip? And then back up. So the resonant frequency of this thing is around 15.6 megahertz. And if I'm willing to, you know, dial it in a bit closer, I can like get more precise with it. This definitely isn't an ideal setup. This isn't a very nice function generator. And this was with a test circuit, but you can try stuff out with different coils. You just need to make sure that the resonant frequency of the coil is below the resonant frequency, the maximum frequency that your function generator can generate. Otherwise, I'll show you what it looks like when you hook it up wrong to a coil that's not suitable. Now, I might have done something wrong. I'm not sure. This is something I'm testing out, so I can't be positive. But this is not the expected behavior. Actually, wrong way. On the other side of the current limiting resistor, and then the function generator gets hooked up on the protected side. And your fucking thing. Clip on there. Okay, so I've got the output, and this one, because of the like impedance mismatch in here, like it dramatically reduced the output. So let me auto set it again so you can get a scale factor. But unfortunately, you can see if I bring the frequency up, the voltage goes up. But if I bring the frequency down all the way up to the maximum, it just continues to go down until I get to 25 megahertz. So this one's probably got a resonant frequency that's too high. Or there could be some other anomalous behavior. When you mix inductors and capacitors, they create reactance, like capacitive reactance and inductive reactance, and that creates really weird behavior when you're measuring voltage. So I'm not sure what I did wrong, but you can try it out with different coils, and with your low frequency coils, like really low frequency, like in the hundreds of hertz, it should be pretty evident, because when you get up there, you know, you'll have a lot of range that you can work in, and you won't, you know, just one click will give you a lot of data. So try it out, let me know what you think.